Hello, everyone. Thank you so much for joining Fortress Power and our informational webinar today. My name is Jamie Brill, and I'm the marketing manager here at Fortress. Today, Jing Yu, our CEO, will be explaining the design and installation of lithium storage systems. She will go over a brief introduction of our company and product, how to design lithium battery bank for your product, how to properly install lithium batteries, and how to program the inverters and change controllers. There will be a chance to ask questions at the end of the presentation. So let's get started. Please welcome Jing Yu.
Thank you, Jamie, for the introduction. So first of all, I want to make sure all of you can hear us good. So if any of you have a problem to hear, please just type into the question section, okay? And Jamie will help me to monitoring those questions throughout the presentation. And also we're going to send the presentation slides as well, including the webinar recording, so that way you can share with your co-workers or your partners. Okay, let's get started. So my name is Jing Yu. Just a brief introduction about myself. I've been in solar many years. I obtained my electrical engineer degree back in Germany, and then I also got my master of business administration there as well. So I was very fortunate to be able to work in this renewable energy in Germany as well as here in the United States. And again, it's hard for me to imagine to work in any other field than the solar and the renewable energy. So I truly love what I'm doing, and I'm sure a lot of you, probably share the same value. So today we're here to cover the following talks. We're going to talk about a product, our company. And I also add a section here is a battery technology comparison, because again, we go to a lot of trade shows, people still want to know, well, what's the difference between a lithium iron phosphate and lithium ion? And what's the difference between, why should I go with a lithium instead of lead acid batteries? So we're going to have a section to cover that. And then we're going to really dive into when you design a lithium energy storage, especially when you come down to select inverter and the battery bank. What are the steps you have to go through? Then we're also going to cover the installation that's primarily focused on the Fortress battery, because I know some of the folks that you already installed or you already purchased or installed Fortress battery. So I want to kind of refresh that, make sure that you install the system properly to give your customer best value. And then we're also going to touch base briefly about parameter setting. So Fortress Power, who we are based in Southampton, Pennsylvania. So we really bring the lithium ferro or lithium iron phosphate battery from the automotive to the energy storage sectors. And later on, we're going to cover why we choose this technology. We have a 30,000 square foot facility here. We do R&D testing, as well as we have our sales and logistics team here as well. So all the service support also going to be come out of this facility. We do have a logistics center in California and Florida, so we can serve the customers in the West Coast as well as down the South Caribbean, Central Caribbean, as well as South America market. We have about 45 megawatt installed worldwide, from Canada down to South America, Africa, and also we're penetrating to Europe and Australia market as well. We also seen that a lot of government applications for the lithium battery, from railway, from military, and some other sectors. And in fact, we are exclusive supply for a local railway company here. Our factories are based in China, in Shenzhen. It's actually, if any of you been in China, this is considered to be Silicon Valley in the East. So it's a lot of high-tech company, a lot of smart engineers there. We are ISO and OSAS certified, so we're up to the standard requirement. The factory's been making lithium iron phosphate battery since 2008. So again, this is a proven technology. Now, if you look on the lithium ion battery, which really started gaining popularity starting 2015, and we're gonna, again, later on, I'm gonna explain the differences. We have about a 1 gigawatt production capacity in this facility. Now, if you look at the global supply chain, The 90% of lithium capacity still goes to automotive, and 10% are going through to the energy storage and the consumer product. And thanks to the large deployment in automotive, that has brought the price of lithium batteries down dramatically. Here are the 3 products that we currently offer. Start with the bigger one, it's 18.5. Then move to the 10 and 5. 18.5 we see are more popular here in the US and Canada because we are bigger energy consumers. The 5 and 10 are more for other countries. Also want to quickly introduce the new product line we are launching in Q2. This is a unit that can be fit to the standard server rack. You can also mount on the wall as well. So if you're in a flood zone, you want to make sure that the battery packs are on the wall, you can do it. It's about 100 pounds, so you can handle that. We also add a few new features to it. It has SD card for data storage, so anytime we can go back, look at how the battery was used, in terms of voltage, amperage, temperature, and down to the cell level, not just the whole pack, but also the cell level. It also has built-in Wi-Fi remote monitoring. We also working on the cloud-based monitoring solution, and that gonna really makes very easy. If there is an issue, you can log in to see it. Your customer can log in, and of course, we as a manufacturer will be able to log in too. It will save you a trip to the field and trying to test the battery. That's how you handle these days with a lot of lead acids or even lithium batteries. Here are the basic technical information here. We're not going to go each one in depth, but basically, there's amp hour rating, start from the big unit to small unit. The lithium battery, because it has battery management systems, so it has maximum charging, discharging current, so that you want to make sure when you select inverters that you can operating that within that parameter window. It also allows surge because, as you know, the inverter these days can also provide surge, and it's especially critical if during off-grid applications. So the BMS is also designed to accommodate that surge capacity that you need. The eVolt and eFlex, you can stack multiple units, and the reasons because we have a communication cable that connect between those batteries, and during the operations, the master will monitoring the slave units and make sure they're always on the same page. The 10 and the 5, they do not have communication, and we're being conservative. That's why we only allow you to stack 2 or 3 of them. And the eVolt has also a monitoring. Again, if you have clients that are not very technical savvy, they can go on the apps, then they have some local monitoring that can view the state of charge. The eVolt, eFlex, like I mentioned, they enable communication, not just between the batteries, but also with inverters as well. So by doing so, the BMS will be reporting the state of charge and amperage, temperature, all those information to the inverter. That's the most accurate way for inverter to get information. They all come with a breaker, DC breaker for over-surge protecting. We offer in US and Canada, we start with 10 years warranty. In other countries, we start with a 5, but there's an option for you to actually extend another 5 years warranty. People may ask why you do that. It's because, first of all, 5 years warranty, of course, comes with a little lower price tag, but also we need to learn more about the market and know that, the environment and how people put the system together. And if we're comfortable, we move up 10 years. Actually, we also move up a few countries in Caribbean to 10 years. We just want to be conservative. But again, in both cases, we'll guarantee 6,000 cycles at 80% DOD. Now, I want to also get a chance to dive a little bit more into the battery management systems. This is some of you probably familiar with that, but some of you, if you use lead acid battery, you might wondering what a battery management system does. So first of all, there are two types of battery management systems widely used on the market for lithium battery. One's MOSFET, another is contact-based battery management system. So the MOSFET is, more simple design, more compact, small. The 5 and 10, we use the MOSFET, so it provides over and deep discharging protection. Of course, if it's overheated or low temperature, it will protect the battery cell as well. And if it's over current surge capacity surge from the inverter, then the BMS will also protect itself. Or if it's a short circuits, happening in the battery, or if there's open circuit, the system will shut off as well, just protect itself. It also monitoring the cell level information and balance them, make sure they are, during lifespans on the same voltage level, similar amp hour capacity, and that make sure they last as long as they can. Now the 5 or 10, we also use a cylindrical cell. Those are smaller, like your AA batteries. They're more flexible to be fit into enclosure, can allow more flexible design. The eVolt and eFlex, we use a contact-based BMS. So you have relay, you have fuse there. They can handle much more charging, discharging current, as well as the surge capacity. It covers all what the MOSFET BMS does, but in addition, we allowed you to communicate with inverters and communicate between the batteries in parallel, as well as remote monitoring that we are working on that. That should be also available next few months. This one we use prismatic cell for those eVolt and eFlex. Prismatic cells rectangle shape that has better power density, and also in terms of degradation rates also better. They're slower. So it's for large systems that we really recommend eVolt 18.5 and eFlex 5.4. It's just much better for your system's performance. This is how the local monitoring of the eVolt looks like. You have the voltage, the SOC as a state of charge, the charging, discharging current, and also the power, charging, discharging power. If you look here, you can one will be set as a master. If you have other units, you would set other units as a slave. It has also the error message here. You're showing you if there's an issue, for example, with a high voltage, then the lights, the HV here will turn in red. That enables your customer, if they go and see an issue, they can, let you know. But also when that's online ported and up running, then you will also be able to get error message as well. Okay, so let's take a look at a battery technology comparison. Now, there are many battery lithium chemistries available on the market. Primary three chemistry are widely used in automotive and consumer and energy storage application. We focus on lithium ferro, or you can name it lithium iron phosphate, LFP chemistry, or LiFePO. They all talk about the same chemistry, so I want to bring you to the, make you aware of that, because you could be confusing if you read different articles and different specs. The Tesla, LG, Panasonic, they focus on lithium ion or nickel, magnesium, cobalt. This is or short terms NMC, and then harmless use actually lithium polymer, so LiFePO chemistry. Now, why we choose the lithium iron phosphate is because it's safe, it can be fully recycled, and it has very good thermal stability. And also, it can deliver much more cycles, which is critical, especially if you're a design system for off-grid or for commercial applications. The cycles are, do matters, or like California for time of use. If you need anywhere, 1 cycle a day, then it's really getting critical. That cycle is going to really help you to reduce the cost in the long run. And LFP chemistry also degrades, much slower than the other NMC and the LiFePO. That's why it lasts also longer. It, delivers more cycles. Now, in terms of the energy density, then the LFP has the lowest energy density. That's why the nickel, manganese, cobalt are more favored by the automotive company because they need to pack as many kilowatts hour in a certain space. The cost, the price tag of the cost depends on the mileage, how much you can drive for one full charge. But for energy storage, safety cycles it's more important. That's why you've seen that consumers or installers are now towards move to lithium iron phosphate technology. Here, just a video on YouTube. You can take a look. It shows how when a nail basically draws through the cell, creates the temperature goes up and creates a short circuit, how the battery cell is going to react to that. You'll be very amazed that the nickel, manganese, cobalt actually catches fire right away, while LFP actually just has some smoke. So it's much safer. Now, also another distinguish from a LFP or lithium battery in general than the traditional lead acids family is when you live in Caribbean, for example, and then you need to turn on your air conditioning. Then if you have lead acids batteries, then of suddenly you can see the battery will dry very quickly, and it's supposed to last, you expect to last for 2 hours and maybe turn out to be like 30 minutes. With the lithium, you do not have that issue as long as you're operating within the maximum discharging amperage. That capacity will not drop, so you can expect the battery to last, if it's 2 hours, it's going to be 2 hours. And also, when you design a system, if you have lead acid systems and you're going to move to lithium, it's critical to know that lead acids, the depth of discharge is only 50%, so you only get 50% of the nameplate capacity. With the lithium, you can go 100%. We typically suggest you either 90% or 80% of depth of discharge, depends on applications. And also, lead acids capacity is more being affected by not just the discharging rate, but also the temperature and the depth of discharge. Now, if you look at the statistics shows that over 90% of the global energy storage installed last year are paired with the lithium. And why is that? Is because there's just a lot of advantage with the lithium chemistry, and also, like I mentioned, LFP chemistry is also again a lot of more popularity in the energy storage applications because of the long life cycles, the safety, and also the efficiency here. So let's go over these charts here. When we talk about renewable energy, efficiency is always very important. So the LFP chemistry, among all the chemistries we have here, has the best round trip efficiency. That means if you have a 10 kilowatt hour battery bank, you charge with 10 kilowatt hours solar, and then you can get 9.8 out of that battery. With a flooded AGM, you can see the substantially less. And if in terms of life cycles, we guarantee 6,000 cycles at 80% DOD, and that's how the other chemistry is gonna, how many cycles they would delivery. The nickel iron is pretty good, 8,000 cycles. Off-grid years, if you count 1 cycle per year, or 1 cycle per day, sorry, and that's how many years you can expect the battery to last. LFP, you can expect around 16 years. Nickel iron, is the best, 22 years. But flooded AGM are, if you do 80% DOD, you really talk about a year or two if you do that every day. Energy throughput, this is an important term. The energy throughput is the total amount of energy that a battery can be expected to store and deliver over its lifetime. So how does this come is, this here is the formula. You have energy throughput, which is going to be equal to the nominal capacity of the battery. In this case, it's a 10 kilowatt hour. Multiply double discharge, it's 80%. Multiply efficiency, 98%, and multiply the guaranteed life cycles, 6,000. In that cases, you will get 47 megawatt hour with one of our LFP10. Nickel iron is, nickel iron is about number 2. It's around 41.6 megawatt hour, and the other ones, are substantially less. Now, if you take an out-of-pocket cost to divide it, the energy throughput, then you will get, the cost per kilowatt hour. So you can see that LFP chemistry that we offer delivers at 14 cents per kilowatt hour, and AGMs are substantially more. You talk about, 3 or 4 times more. So this is how you do an apple-to-apple comparison. Again, at the end of the day, energy cost is calculated by how much cents per kilowatt hour. A quick summary: the LFP chemistry, we talk about the safety. It has very high energy throughput, longer duration. Among all the chemistry, it lasts longest, and that also leads to the lowest energy cost. Before we start to design one systems step by step, here's a list of inverters that we are compatible with. The way the battery design is that you can work with the different inverters as long as they requires 48 volts and DC input. You can use communication, or you can skip the communication for if you parallel eVolt or in the future eFlex. We are working with the Schneider SOAC SMA on the communication. The other batteries that are currently we do not communicate with them. But again, you can just use the parameter setting in the inverters, and that will works fine too. Now I'm going to use a Schneider inverter as an example because this is equipment that you have. It's very flexible in terms of when you design them. You can depends on your PV array determine how many charge controllers you want, and also depends on your load, how big your critical load panel is. You can select inverter sizes, and then depends on your what day of how many day of autonomy you want to achieve. Then you can select the battery banks. It also can do single phase and 3-phase. It supports almost all the application need off-grid, time of use, load shifting, backup, or grid export. And because inverter and charge controller are separate, you can also allow you to DC AC. If you do DC coupling, you need a charge controller. If you don't do the DC coupling, if you want AC coupled to existing PV inverters, then you can just use the inverter and without the charge controller. You can also hook up the generator as as a second backup power source. Here's the specs. We're going to focus today use the 6848 inverter as an example to design the systems. So we have developed storage sizing tool that for our authorized installers. The sizing tool is Excel based. It's really simple to use. It has, mainly involves 4 steps. Once you want to select the critical load circuits, or you can also name as your backup circuits. So you can go to a customers and figure out what do they want to be, powered during the power outage, or what's their priority circuits. Let's put it this way. And then based on the circuits that you selected, you can get a daily usage to determine how big the battery bank you want to have. At the end, you can also give your customer a breakdown of the average production and consumption of the house, kind of like help them to adjust their consumption behavior during the summer and the winter season, because you know, in some here, like here in the Northeast, that solar radiation ratio between some of the winters 2 to 1. So in summer, you're going to produce a double amount of the solar, which in winter is only half that. How you're going to power your house, it will be completely different. Now, we have listed almost all kind of home appliance in this Excel, and we also categorize it by essential, kitchen, personal appliance, heavy duty equipment. So you can go through that category with your customer and then select the stuff they want to have when the grid goes off. And then, you know, put the quantity here. The starting wattage and running wattage is already built in, so it will come automatically. And then you can choose, you know, hours of operation per day. Some appliances that we already have built in suggested operating hours, such as Energy Star rated refrigerator and freezer. The compressor turns on off, so it's about 80 hours. In that case, is, you know, not 24 hours, 8 hours. So it gives you more accurate number. So here, based on for this particular project, that's what we selected. And so you can see that total starting wattage requirement it's 7.3 kW, and the running wattage is about 5.1 kW. We select one Schneider inverter, and it will shows you that, you know, you still have some surge capacity here available and some running voltage available. So if it's go over that inverter's threshold, then it will turn to be red. Just give you a warning. Now, is that critical? Maybe. It is critical if you have everything running at the same time. So likelihood is low, but again, you know, you do not want to go over too much. Then it could cause a potential issue when clients turn on the appliance the same, you know, as same times, and the inverter can shut off. The total estimate consumption for this home is about 18.4 kilowatt hour. Now we're gonna decide how you're gonna select battery banks, and those are the, you know, a few steps we have to go through. In these cases, we select one XW6848, the, you know, with the two and Schneider MPPT 6140. The array size is about, you know, like around 6 kW. We're gonna use the LP10, and now we're gonna do is, you know, to determine how many LP10 that you need based on the consumption, also based on, you know, the inverter and charge controller that we selected. Here are the 5 steps. Oh, too quick. We need to go through. Now, you know, I have for each step 1 slide, and we're going to go over that. The first thing is based on the total energy consumed. In this case, is 18.4 kilowatt hour. Now you want to make sure the double discharge. You know, you don't want to set, you know, to fully discharge the battery, because if you do that, it will shorten the lifespan. We guarantee, you know, a 90% 3,000 cycles and 80% 6,000 cycles. Now, if you, this project's mainly for backup, so 3,000 cycles is plenty for the customer. That's why we set it up with the use 2 of the LP10, which is about 20.4 kilowatt hour. Total energy, and then the house daily consumption is 18.4. So we set up, you know, at a 90% of double discharge, so that works fine. And second is you want to go check the overcurrent protection device. So basically on the inverter there's a breaker, and there's also a breaker on the battery. Now you want to make sure the inverter's breaker size is basically greater, you know, it's a smaller than the battery bank's breaker size. And why is that? Because in some inverters, they are just being intolerant if you lose the DC power. In a sense, if there's a surge power comes through. If the battery bank size is smaller, then the battery bank gonna shut off first, right? The DC breaker gonna shut off. In that case, some inverter may not handle that very well. They do because they have some control circuits based on the DC side. That's why we suggest that, for instance, like our back Schneider equipment, we suggest that you the battery bank breaker sizes, if you group them together, has to be bigger than the inverter DC breaker size. In this case, if you do 110, the 110 has a 150 amps breaker, which is smaller than inverter breaker. In this case, if surge comes through, the one LFP10 will shut off first, and you don't want to see it. But if you do two of them, two of the 10 for this particular project, then you're good to go. Okay, and then the third step is to check system's maximum discharging current. So you need to check what inverters rating, the continuous rating, as well as the surge rating, and make sure that rating is also equal or smaller than the battery bank's continuous rating and the surge rating. So for instance, in this case is two of the LP10, they allow you to discharge 200 amps because you put them in parallel, so doubling the maximum discharging amperage. In this case, is 200 amps. And the inverter, the 6848 inverter, the continuous discharging amperage is 136 amps. So you're good to go. That means the two battery bank will allow the inverter to draw the maximum amperage at 136 amps. And that's also check the surge capacity, right? The 6848 can surge 12 kW. You use that number divided, battery bank size, the 48 volts or 50 volts. 50 volts more accurate. 50 volts, you're at about 240 amps. That means the inverter can draw 240 amps for about 1 minute out of the battery bank. With the two of the 10, you do not have that concern because they can handle 300 amps continuously. 300 amps, surge. So you're totally fine with that. The step 4 is check maximum charging rate of the charge controller combined with inverters. So in these systems, for example, here we use one XW MPPT 6150 and a one XW 6848. In these cases, the charge controller's maximum charge amperage is 60 amps, and the inverter's maximum charging rate is 120 amps. That's according to the specs. So you want to make sure, again, the same here, the battery bank maximum charge current grouped together can handle that, the combined charging rate from the charge controller and inverter. Because again, the way how the inverter and the charge controller works is if the battery bank goes to low, then you have a solar to charge your battery. At the same time, the inverter can also charge your battery. Of course, if you do not want inverter charge, you can turn it off. But most likely you want to have that because that way battery bank can be charged quickly. So in this cases, if we have the two of the 10 total together, allowing you charging the battery at 160 amps. Now the inverter, and if you allow the inverter and solar to run at a full capacity, you need 180 amps. That's a whole 180 amps together. Now 160 amps is smaller than 180 amps. What's going to happen? You're going to overcharge the battery, right? You don't want to see that. Then what you can do is that the system is designed flexible. What you can do is you can let the charge controller run at a full capacity if there's plenty of sun. But inverter, you can set up the charging rate. You can reduce the charging rate. In this cases, you can reduce to 50%. That way the inverter can only charge the battery at maximum 60 amps. So altogether, now combined together at full capacity, the charge controller and inverter can charge the battery at 120 amps, which is smaller than the 160 amps. Then systems are operate very safe. If you AC couple system, there's a few rules you want to follow. One is, again, I'm sure that a lot of you know the difference between AC and DC coupling, and we cover that also in our other training section. Now, AC coupling, there's one weakness, and this is not a secret. And this work, with all, no matter which solution you actually install, when the grid goes off and your battery is fully charged, and you are not home, it's a sunny day, then your PV inverter is going to produce more than your needs is, your current load. In that cases, through the frequency shift, the hybrid inverter will ask the PV inverter shuts off, because there's basically there's no way to take that additional power. Then they have to shut the PV inverter off. And that's pretty much annoying, to be honest. But this is, again, AC coupling offers another benefit. It's, easy to hook up to your microinverter, to your existing inverter. In that cases, because of that, you want to make sure when you size the array, your PV array, that are not going to not too large for your hybrid inverter to take that that power. So you want your PV array size being equal, smaller than the hybrid inverter, and that way the likelihood is a little bit low that you overpower the systems. And again, the hybrid inverter can also only take that much power. If you put a too big array and it's go over that the hybrid inverter's capacity, the same thing going to happen. It's going to shut the system off, right? In this case, for example, if you use one XW6848 to AC couple in-phase microinverter, you want to make sure your PV array is smaller than 6.8. That is rule one. And then rule number two, the same. If you have the no load, let's say, and you use the PV production to charge the battery, in that cases, you want to make sure that the battery bank is big enough to handle that charging amperage from the PV array. In this case, as an example, if the PV array is 6.5 kW, the battery maximum charging rate needs to be greater or equal to 135 amps. So you take 6.5 kW divide 48 volts, going to be equal to 135 amps. That way you can make sure that the battery banks can handle the PV production at its peak time without any, cause any problems. Here, just a quickly, the tool, the Excel-based tools will give you a consumption report, tell you what's the select circuits and their consumption average per day. In this case, we select 2 of the 10. And then what's another thing that we offer is that you can break down the PV productions by months. Now, this is a project installed, I think, in North Carolina. As you can see, in June, it's a 9 kW system. In June, that it's produce average per day 36 kilowatt hour. So if your battery is fully discharged, half of that can go charge the battery, and the other half already can power the circuits during the day. So you might be able to use more, like more heavy duty appliance, or even turn on your window AC units, for example. In December, your production of the systems run at 21 kilowatt hour. In that case, if your battery is fully discharged the night before, then you want to make sure that most of the power go to charge the battery. So during the day, you'll be more conservative. It just helps in customers to understand that the PV production, it's different between the months, and then how they should behave, adjust their consumption behavior. And we talk about, in off-grid, and when the grid is off, during power outage. Okay, so we're going to cover the installation guide here. We have now, if we don't offer the battery cables, you will need to select the battery cables. Depends on the system sizes. There's a national requirement for wiring and cables that you select. Typically for the small 5 and 10, people will choose 2-arc, and for the eVolt, people will choose a 4-arc copper wires. The battery has knockout on both sides, so you can use a conduit and to cover all the wires. Now, I want to also talk about when you are hooked up to inverters, some inverters like Outback and Radiance, they all have very high, inverters in general have very high surge, or called like a rush current. When you flip the brake on, it can go up to 1900 amps, but for a very short time period, a few milliseconds. And because of that, and there's certain steps to follow. So if you just have if the inverter just one breaker, you would do is you put a battery brake on first, and then you turn on the inverter, because a lot of inverter actually requires you have the battery to be on first and then to turn on the inverter. And if you have inverter with 2 breaks or more, such as Outback Radiance, there's 2 breakers there, then you will basically finish the step 1 here as above, turn on the battery breaker, and then you can turn 1 inverter breakers. And then after a few minutes, you can turn on the other inverter breakers. Because again, if you do 2 breaks at the same time, that surge, that rush current is going to doubling, and that's very, very high. We're talking, 3600 amps. With the eVolt, you have we are using the button in the front to turn on off the BMS. So that would be the first thing you want to do is push the button, activate the BMS, and then there's a breaker, turn the breaker, and then turn on the inverters. If you do with the Radiance the same, you do the step 1, step 2, but then you can turn 1 break first and let it rest a little bit, and then turn the second breaker on for the same matter that we just discussed about. If you want to parallel multiple batteries, that we always suggest that use a bus bar, and there's a few things you want to make sure that you can hook up with M8 terminal ring. It's a 48 volts rating, and then you look up the maximum amperage, charging discharging amperage that of the battery, and decide how big the terminal bus bar needs to be. And there are, some customers also make their own bus bar. Can be very inexpensive. You go with a midnight, it's nice. Look, it's a little bit more pricey, but you can also make your own ones. Now, if you parallel the 5 and 10, there's a few things important. First of all, you use the bus bar. You make sure the cables are the same length. That way, there's no voltage or resistance difference between the batteries. And the second is that it's important that when you're doing operations, have the inverter first off and have the battery turn on first, and then to turn on the inverters. With the eVolt, it's a little bit more steps here. Like I mentioned, you have it comes with the RG45 cables, and then you can daisy chain them, so they will communicate with each other. You always start with IS45 to CAN, IS45 to CAN, And then also, when it's connected, you will see if the battery voltage between the batteries greater than 0.5 volts, then the one that with a lower voltage will not be turned on. And again, it's just prevent if you have two battery put in parallel and the voltage is big, difference is too big, then the one with a high voltage can charge the one with a low voltage and can send a very high power. It could be a couple hundred amps and you could damage that. That's also with the EVO, you don't have that concern when you have communication cable connected, because it will prevent that. With with the 5 and 10, that's something you will really want to pay attention, that voltage difference between the batteries being less than 0.5 volts. Okay, that's the differences. Now, a lot of inverters, they allow you to set up the parameters in inverter or charge controller. And this is our, the parameter settings for the 5 and 10 and 18.5. We do also have more in-depth, more detailed battery parameter setting guidance with the Schneider, Outback, SMA, SOARC, and some other inverters on the market. Now here, we already touched base that already, but I just want to emphasize, if you want to make sure if you have use the inverters data, you can flexibly group the charge controller and inverter together. Make sure that you set up the inverter and the charge controller's charging rate properly. The rule is usually you let them charge controller run at full capacity, because you want to take advantage of the solar. And on the inverter side, you can set up the charging rate in a lower percentage. That way, you still can use the charge controller to charge the battery, but will not harm the batteries at all. If you have other applications, if time of use, self-supply, or demand curtailment, you're welcome to email to sales@fortresspower.com, and we can use a third-party tool to help you design the systems. We have an installer form that if any of you want to become authorized installers, you can fill the form. We can email you and sign up. Very easy, and we will train you, provide product and sales training, and then as well as the design installation training. It can be webinar based. We also work with a lot of distributors and provide on-site training as well. Here's our contact information. Okay, let's pull out some questions, see if you guys have any questions.
Nothing yet, but
okay,
let us know if you have a question.
Let's see here.
You just have to go into the chat and type in any question. I think
there's one.
Raj Gupta, I know that he asked about the meaning of throughput. So I know that Jane covered that in her slides. Let me know if you got your question answered.
Yeah, and also trying to see how we're going to plot this question.
Go to the chat here.
Oh, the chat here. Okay, and we can pull it out. Okay. Oh, Jim is one section too. On the question section. Okay, so we get a lot of questions coming. And we're going to go over that, okay? Good.
Okay. So let's see, I'm having sound problems. Will this recording be shared in the coming days? Yes, it should be shared. It should be shared right away.
Okay, it looks like some folks have a little bit problem with the sound. Maybe, maybe
I think it came back.
Yeah.
Can I buy the eVolt 18.5 unit in the US and transport it by air to Africa?
By air is a little bit tough, because air shipping with the lithium battery is a lot of paperwork, and especially for that large unit, it's going to be tough. I know you can ship smaller units. We ship the L 5 kilowatt hour, that's fine, but 18.5 we never tried.
Okay, another question from Russell comes in. Is the warranty prorated?
The first 12 months not, and after 12 months it's prorated. But again, I always say that a warranty is written by lawyer. In reality, if you have customer and we do not want to lose a business, if there's a problem, we have to take care of that. Otherwise, how we can get you buy again.
Okay. Drew asked, 14 cents is 3 times the cost of solar. Shouldn't one use solar direct and turn off fossil before resorting to storage?
Well, if you use a fossil fuel, now we talk about it here, it's for backup and also for time of use application, demand curtailment. Those are not just purely solar can offer. That's why you need a battery. You can certainly use a generator, but generator cost, running cost much higher. The fossil fuel, if you want to get, gasoline, how much that gonna cost you? We know it's 40, 60 cents per kilowatt hour. So you're still 3 times more expensive.
Okay. Chris asked, I'd like to see an example of sizing your LFP versus FLA. I say FLA because this is what most of us old-time installers have been using. So a commonly sized off-grid system is 1350 amps hours or 6.4 kilowatt hours at 48 volts. So how many e-volts, 18.5 kilowatts, would I need to use to replace my many clients' old FLA?
Sure. Now, Chris, I can send you an email about that, but briefly to cover that, if you have a 13, let's use 1300, as example, 1300 amp hour. Now, the really usable capacity is only half of that, right? In that case, it's going to be 650 amp hour. So you will use a 650 amp hour to divide it 0.8 if you want to set up 80% of the discharge, and that number is going to be the equal lithium amp hour you need. You use a 350 amp hour divided by 0.8, so it's probably around 900 some amp hour. But I'll be more than happy to share that formula, email to you.
Okay. Another question. Drew is asking, solar would never get 80 plus 80.
I don't know that what that question is. That Drew, if you like, we can certainly have a phone call to answer that. But I do not understand what do you mean 80 plus 80.
Well, lastly, okay. When you have multiple battery banks, is it possible to schedule preferred battery discharge as opposed to all batteries discharging together? Such prioritizing or scheduling may enable smaller charging to a select few discharged batteries, much like several DG sets and varying loads.
Okay, Rafi, I'm trying to understand what you would like to achieve here. So when you have multiple battery banks, you can usually people will hook up to the central, group the battery, put in parallel to get one battery bank. And by doing that, you still can allow you to prioritize your charging circuits. I haven't seen a system that you want to design that way. You want, discharge a few battery first and let other batteries sitting there, because that way the ones that always get discharged first, you might short the lifespan of that. That's why common practice is, put all the battery bank in parallel and group together as one battery bank. I hope that I answer your question. If not, Raf, you have my email. You're more than welcome to email me.
Okay. Matthew's asking, have you ever had any surge issues with the Solarc 8K and the eVolt 16.5?
Not I'm aware of, because the Solarc 8K will draw about 8 kW power from continuously from the battery bank, and the eVolt 16.5 can handle continuously close to actually 9.2 on the specs. In reality, you can close to 10 kW if you push the BMS limit. In terms of the surge, we designed that BMS can handle that surge for the for the surge, the 20 kW surge for 5 seconds. So our BMS should be able to handle that.
Okay. Chris is asking, if only taking battery to SOC of 50% each day, will this extend its life?
Correct.
Are you okay with the battery doesn't see a full charge each and every day?
Correct, Chris. If you set up 50% SOC, you can really, expect the battery can last for 10,000 cycles. It's okay that you don't have to do a full charge and discharge every day. It's different than lead acid battery. But we generally recommend, at least every 6 months you do a full charge discharging. And a lot of inverters can be set it to do a, one equalization, fully charged and discharging.
Okay. Nate is asking, what is your current experience advice regarding SGIP in California?
Yeah, for the S-chip incentives, we have our e-vote listed there. I mean, how many of our customers use S-chip? I don't know, because I know S-chip incentives can go away very quickly, and when it's available, unfortunately, company like Sunrun or Sonova, for whatever reason, they get a lot of chunk of their money, and it's not too many left over for other contractors.
Matthew is asking, is there an estimate for pricing on the eFlex battery?
Yes, will come out soon. We're being, conservative. We want to make sure when we release the price and the products it's on the cargo, on the boat to us.
Okay. Nancy is asking how to become an authorized dealer.
Nancy, we can send you a form and then you can fill it out. And then, we would really just want to know that you have enough experience of building solar. And if you already have installed a battery backup system, even better. So that we know what level of training that you need.
Okay. Joe is asking, Joe left. Let's answer Mike's question. Which inverters do you communicate with for paralleling?
The paralleling, like a Schneider XW Pro, we'll work on that, and also the SOARC. And the next thing we work on is SMA. The way how it communicates is that you will have the master. The master will communicate with the slave, and the master will report information to the inverter. That's one way of doing that. With the Schneider XW Pro, you can also basically, there's no master-slave relationship between the batteries. You can use everyone as a master, and each of the units can report information to the XW Pro as well. So there's two ways of doing that.
Okay. Dean is asking, are the batteries designed to UL 9540?
Well, again, the batteries, the certification of the batteries is 9073. The 9540 is that when you group inverter and battery together, if you do a solution like Tesla as a containerized solution, then you will need a UL 9540. But as a battery manufacturer, we, so far we focus on the 9073, but we are looking to also, partner with a few inverter company to do a 9540. But again, 9540 is a inverter and battery combined together testing.
Philip is asking, is it possible to connect eVolt battery with Mercer inverter?
Messer. Yeah, I don't know about that inverter, but you're welcome to email us the specs and we can take a look, go over that. And if we need, we can also talk to the inverter manufacturer.
Dan is asking, do you make your own BMS and are they available for purchase?
Yes, but we don't make them available for purchase, and it's mainly for our own applications.
Okay, Richard is asking, when is the next available installer training class?
I mean, we have a lot of trainings actually lined up with the CD Green Tech. We're lined up trainings here in the Northeast, and also with the Schneider, we have also training in Florida. On the web training, we're looking the next web training maybe in 2-3 weeks.
Are they free to attend, and where are they located? So you said CD Green Tech?
Yeah, CD Green Tech is in Albany location, and maybe also Rochester, and the other trainings in Florida is in Miami, jointly with Schneider.
Is there a fee to attend?
I don't think so, but you will have to pay your flight tickets, and also your hotel.
Okay. Are these batteries compatible with generators for off-grid solutions?
Yeah. Now, again, between the generator and the battery, there's a hybrid inverter. Like in this case, Schneider, you can do it. Outback, you can also hook up. SARC inverter, the same. Magnum, you can all hook up the generator and use the generator to power the load and to charge the battery.
Okay. Chris is asking what kind of NEC code chart changes are going to be required for lithium?
NEC code, it depends which code you talk about. The code, if you do 2017 actually doesn't really have a strict code requirement. They just tell you, they suggest you for 9073 or 9540. If you go with the 2020, if you, again, with the 2020 NEC book, if you have energy storage, which inverter and battery combined together, they will require 9540 test. But that's assume you provide both together on the same brand.
Okay. Ryan is asking, when will solar converters directly communicate with Fortress eVolt batteries?
So actually, we are testing it. It's already communicating. We should hope to release that soon. We're just waiting for also, the SARC to confirm that.
Okay. Jose is asking, PWM charge controllers work well with Fortress? PWM charge controllers.
And again, this is, I haven't heard that. Can you please email us the specs? I know there's a lot of inverters that are used, in other part of the world. But we're more than happy to take a look and work with the inverter company.
Okay, Mike is asking, do you have any communications applications to add value streams of peak load shaving and time of use high utility cost avoidance? Or is this all third party or inverter software application?
So can you repeat that question one more time?
Yes.
Jamie, for me, please.
Do you have any communications applications to add value streams of peak load shaving and time of use high utility cost avoidance?
Yeah.
Or is this all third party or inverter software application?
This is an inverter software application, especially like time of use. Most of inverters, you can set up the time window to shave the demand charge. And if you want to do the peak load shaving or like a demand, you call it demand curtailment, then some inverter can do it. Some inverter cannot. Then you need a third party unit. We actually do work with a company, a third party. They have that control unit that can help you to curtail demand charge especially for commercial buildings.
Okay. Richard is asking, can you run the power back and forth from the grid with this battery?
Depends on utility. I know you can certainly take the power from the grid, but if you can feed the battery power back to grid, it depends on utility, right? A lot of utility do not allow you to feed the battery power back to grid for net metering purpose.
Okay. Philip is asking, how many eVolt batteries can I connect in parallel and in series in case I want to put in a solar farm?
You can only put in parallel and up to 12 units. You cannot put them in serial. It's not designed for, in serial to build a higher voltage.
Okay. Ryan is asking, do you know any possible ways to use a Schneider 6848 AC coupled for daily self-consumption?
I think that's doable because according to my knowledge, you can, set up a self-supply mode for that. If you're interested, we can connect you with a Schneider team and they can, provide you more information about it. But it definitely enables you to do self-supply.
Okay, we were asking, I have a question have you shipped to Africa before? If so, what can be short delivery time? My clients here are interested in knowing if they can order and trust that their products are going to be good condition.
Yeah, we did ship to Africa. The lead times from here somewhere 3 to 4 weeks. 3 to 4 weeks.
And do they come in good condition when they get to Africa?
Yes, definitely, because we also ship that from, our factory in China to here, and that's also 35 days on the ocean. So we pack each battery in a wood crate and, very, very robust packaging.
Okay. Gary is asking, can we install the battery in a basement of a residential house, or is there any regulation about this in the US and Canada? How about the temperature requirements for the battery?
I'm not aware of any regulation. You can certainly put in your basement. Basement is probably a good place to put a battery because usually, you know, even you're in the Northeast or Canada, you usually want to have your basement temperature to be above, you know, of 40, 50 degree. You don't want it in the freezing to frozen your water piper. So battery basement is a perfect spot.
Alexis is asking, if the battery is disconnected from the inverter for a couple of hours, the customer needs to follow the commissioning procedure too, right?
Yeah, if it's disconnected from the inverter, then you have to go through the same steps. Yeah, you have to, you know, flip the battery breaker first and then turn on the inverters.
William is asking, have you experienced global supply slowdowns because of the coronavirus impacts?
Well, that has impact everybody. I mean, you don't see in this, you know, and you don't see it right now because, you know, all the suppliers have a distributor or manufacturer, they have a stock. But another month or two, you will see that a lot of you will see the market shortage. But again, we communicate, you know, with our folks in China. Well, a lot of factories are actually back to work. I think another week or two, the things will be more established.
Okay. Chris is asking, I have installed several of the e-volts and in one case had some difficulty getting the master slave to work correctly. Tech support had me put both batteries and the master voltage was the same and it worked perfectly. I have a system with 4 e-volts and I'm installing soon. Can I put all 4 in master in the voltage within 5?
Yeah, you can do that, but I'm surprised why the mass slave doesn't work, you know, properly. I'll be very, we certainly need to dig into that. But if you want to set up all in the master, you can do that. But like you mentioned, the critical is when you turn it on, you make sure the voltage difference between them are smaller than 0.5 volts.
Trimore is asking that he's saying that he's an authorized dealer and installer. His company is located in Southern Africa.
Mm-hmm.
And due to rampant power outages, how can they benefit from some of these presentations that if we're using them to penetrate our current market, it's flooded with earlier lithium ion technology and flooded batteries, lead acid and gel. Major competitor here is Tesla and Blue Nova, but they are rather expensive.
Yeah, if we can help, we certainly more than happy to help you to educate the customers there. We can do, you know, like a training, webinar training. Depends if we can, you know, form a distribution relationship. If you want us to come to your facility and you can group up, you know, a bunch of installers together, we'd be more than happy to do that. That's how we also help a lot of other distribution partners we have in outside of US, you know, to build up their market.
Ryan is asking also, what voltage is the batteries considered to be 20% SOC or 80 DOD?
At the 20% SOC, your battery for the LFP chemistry, you are around 49 volts.
Drew is asking, I don't know, it's PWM pulse width modulated.
Yeah, it's PWM pulse. Yeah, that charge controller works. You have 2 type of charge controller, you know, the PWM that should work.
Okay. Nancy's asking, have you integrated with Lithium or other load shedding consumption management systems for residential systems?
Looming. We haven't tried Looming. You know, we actually find it interesting. We had one time at trade show last year, SPR, Looming just crossed, you know, just actually next to us. We haven't, but I know that our engineering team are looking to get a Looming to test it out. According to my knowledge, Looming is pretty, you know, diagnostic, so they should work. And again, we also use a standard communication protocol. If that requires communication, that should be pretty straightforward.
Nate is asking, with the third-party demand management app, is there modeling available?
Yeah.
Okay.
The best way, Nate, is if you have a project, you send us a project information, 15 minutes interval data for 12 months, and that'll be a good starting point.
We have a question. Are these batteries installed in the Gulf region? Because
Yeah,
the weather here is very harsh.
yeah. We have, we have a lot of customers in Central Caribbean. Actually, it's very attractive market for us.
Dan, you will be receiving a copy of these slides after the webinar is over. Yes. Richard, any plans to have your batteries compatible with storage inverters?
Yes. We are looking to started designing high voltage battery once we have the E-Flex on the market. And the high voltage battery that the one of our target is to work with the storage or solar age hybrid inverter, SMA, and some other hybrid inverters. They focus on high voltage DC input.
And the last question we have is from Carlos. How is physically connected the communication between a XW Pro and an eVolt 18.5 kilowatt?
Yeah, you use, communication cable. So there are typical, RS485 cable. With the Schneider XW Pro, sorry, I have to correct that. It will go through a gateway. So the gateway will sit in between, will translate the ZAM bus protocol to Modbus, and then Modbus will communicate with our BMS.
Okay. Let's see, we have some more coming in.
Yeah.
Ryan is asking, how can the SOC at 20% be at 49 volt when the LBCO is at 50.3 or 50.7?
Yeah, that's actually a very good question. I just, on top of my head is around 49 volts. Now usually on the inverter side, you want to set up the voltage a little bit high because between inverter and the battery, there's also voltage differences. So I think, 49 volts, I give you that information should not be accurate. The 50.3 should be, more accurate for that. I just was, think on top of my head.
Okay. Philip is asking, is there a practical training session in US? Is it also important to get knowledgeable and also the training together?
Yeah.
And last one here is emphasize AC coupling limitations.
Emphasize AC coupling, there's no really limitation, but I heard from a few installers is that when you AC couple to Enphase for whatever reason, when you're on a cloudy day, your PV and the batteries are running low, and you only have a few lights on, you have a light flicker, and that a problem you have with a mini hybrid inverter if you do AC coupling. And it might be it's caused by Enphase micro inverters.
And we have another one here from Carlos. Could you provide instructions on how to set communications between XW Pro and eVolt?
Sure. Once we have that available, I know that the engineers are working on that, get instruction.
And we have one here. How can we acquire a certification training?
Yeah, I mean, we can do web-based. We can do on-site training. If you can, Ashworth, if you can let us know where you're located, and if you can get the dealer form filled out, and we can, discuss it's a web-based or it's an on-site training. See if we can put you, one of on-site trainings that we are having, because we do have a few of them coming up.
Okay. Wow. This was a great session. Thank you everybody for joining us today. If we did not answer your question, please email us at sales@fortresspower.com or either Jing and I at the email addresses provided. All of this recorded session will be on our YouTube page, and we can also put it on our website as well. So check back and we will let you know as soon as we get it. Thank you very much, and we'll talk to you next time.
Thank you guys. Bye. Thank you.